Right, if we can get on to, I'm very excited to hear from our guest speaker. If I can, his bio is very impressive. I'll try, I'll try and limit it. Excuse me. Dr. Reza Mia graduated from the University of Witwatersrand with a medical degree at the age of 23, which is really young. Wasn't happy with that. He then quickly graduated with an MBA from the University of Liverpool. He was subsequently awarded the Dean Scholarship for Entrepreneurship from the London School of Business and Finance for an MSc in Finance and Investment, where he majored in investment banking and capital markets. Most notably, Dr. Reza completed a dissertation in aerospace OEM analysis, way beyond my pay grade, and later obtained his advanced diploma in aesthetic medicine from the Center of Higher Education. Dr. Reza participated in a global study assessing the various injection techniques of Ristoline's skin burster dermal filler. He also became the first doctor in South Africa to complete the Silhouette Soft Advanced Training course. Of great interest to us is a well-known inventor and founder and chairman of Pegasus Universal Aerospace, and holds patents in South Africa, Europe, and the US for a vertical business jet currently being manufactured and actually featured in a blockbuster Hollywood movie. And hopefully Dr. Reza will tell us more about that. He's obviously published many articles and he's appeared in the UK Aesthetics Journal on a number of occasions. Dr. Reza, if I could ask you to please address and inspire us. Thank you.
Hi, everyone. Thank you so much for that introduction. It was very true. So I'm just joking. It's good to start with a joke because it breaks the ice, I always find. I do think that I, I somewhat prefer talking to people in person because then I can tell if they're actually finding my jokes funny or not. That's the limitation, I think, on Teams and Zoom, is that you can't hear people laughing. But I'm happy to be here today. I've already learned a little bit. I've learned, for example, that Adams and Adams does give discounts. I've written that down here for further inspection later on. But that again is another joke. I'm not going to tell you every time I'm joking. But I'm really excited. I'm very honored actually to be here, to be asked to actually speak to all of you. I think it's a real privilege. You could have asked, one of, probably hundreds of people who are innovative and working in these types of ideas. But I'm very grateful and happy that I could be here today. I often find it quite annoying when I go to motivational speaking talks or courses, and I almost feel like somebody's trying to sell to me the idea of inspiration and motivation. And so I thought what I would do for today is rather tell my story and share a little bit about what we've done. Obviously, it's not enough time to tell you everything, but it is enough time to give you an idea about where we are, what we've been doing, and how far we've been able to come with what we've had. So that, I hope, is an inspirational story for you based on what we're doing and what I see for the future in Africa and in innovation in Africa. So I think I'm going to start with sharing some slides just so that we can have an idea about what it is that we're doing. And then I'll move on and I'll start telling you a bit more detail. So I'm logged on here on my computer separately as Dr. Reza presentation. I hope I'm allowed to share this. Yes, I see myself. Okay, good. So what I'll do is I'll share right now. And from there, we can look at the other elements. And I'm happy to take questions at the end. But if you feel a burning question that you really can't wait for, I don't mind if you jump in there. Also, if you have any queries or if it seems like I'm losing my audiovisual capabilities, then please let me know. So in 2012, I sat down with somebody from Georgia. It was the ex-Soviet Union, Georgia. And he wanted us to look at bringing a project that they had for a light jet to South Africa, to build it here, to explore a collaboration. I went to look at the jet and it looked really nice, but it didn't really do anything special. And I thought if we were trying to sell something new from South Africa to the world, it needed to be something really innovative to give them a reason that they couldn't ignore. They shouldn't be able to turn on their TV without seeing our jet. And so this little sketch that I did here is drawn from an F-22 fighter jet. And I actually made this, I think, on PowerPoint. And that's really just to share what the beginning of a project can look like. Often it can look like just a sketch on a paper. Now, for me, it will be either on a CAD modeling software on an iPad. But this is how I did it before. I did it with a PowerPoint, and I just shared some ideas. And that's really where we came from. I'll tell you how we went all the way from there to this. This is Daniel Radcliffe from the movie The Lost City, made by Paramount Pictures. It was released earlier this year. And that's him standing in front of the plane as it lands vertically, really giving a nice illustration and visualization of what the airplane can do. So that was something we were quite excited about with this movie, is it gave us a good platform to showcase what the airplane does. They used it, they flew vertically, they flew horizontally, they landed on a beach, and it was really just exciting for us. And it is exactly what we want people to see for this airplane. It's that you can go wherever you like. You can take off vertically, wherever a helicopter could have landed, plus more areas, because you're not limited by spinning rotor blades above your head that can impact on adjacent structures. So we can land into tighter spaces. And then we can fly through business jet missions. So 6.5 hours at almost 800 kilometers an hour, which means that you're not limited by the speed of a helicopter. And that's kind of the real reason that this is unique. If anybody flies or knows about helicopters, there's a problem that happens when they accelerate or go too fast, in that the fan blade that's moving forward, or the rotor blade that's moving forward, accelerates relative to the helicopter and the airflow. Basically, what I was sharing was some pictures of the full-scale airplane. So let me go back then to 2012. I decided we needed to do something unique, and I started brainstorming something almost just like this. It's how I start all of our new projects. And sitting in the airport in Turkey on the way back, I thought supersonic business jets and vertical takeoff and landing were the two areas that I thought would be desirable. But there's so many challenges with supersonic business jets or supersonic planes at all, which is why the Concorde is gone. And people are spending around the world, billions of dollars to try to fix that problem. And I just thought it's easier to do something with vertical takeoff and landing. And so this is where we started to encounter the challenges that I'd chat a little bit about today, or touch on today, but also speak about how we are overcoming those challenges to make sure that people understand that there are no such thing as real limitations. These are things that we make up in our mind almost, and sometimes it's excuses for ourselves, so that we can say we can't go forward because of these reasons, and they don't have to exist. We can work through them. So the first challenge I encountered was finding engineers who would believe in this type of a concept. When we came up with this, the little toy drones weren't even really popular. No one else had thought about doing eVTOLs and that type of thing. And so it was really strange. I started off at Denel, and I forgot my pen on the table. As I walked back in after the meeting to fetch it, I found some of the engineers almost snickering about the idea that we would think about a vertical takeoff and landing jet. And so obviously I left, I never went back there. But I found some engineers who used to work at Denel, who had worked on the Roy Falk helicopter program. And they said, well, that seems feasible. Let's do a feasibility study. We can't say yes or no for now. Let's look at different ways we can do it. And we did a basic conceptual design study, came up with the idea of the fan and wing system, which means that we can land on grassy patches, in a bush, on a wooden deck, and we wouldn't create hot gas that would damage the surrounding area. The military jets that do VTOL can actually melt tar. And so from there, I then did a financial feasibility study. This is the real reason I was looking to do something. I was looking for a financially feasible project. I wanted to invest my time and energy into something that would reap, big benefits, not just for me, but also for the country. And the financial modeling was really great. That's why when I did my finance masters, I included a research project into aerospace OEM, that's original equipment manufacturing, because I thought I'm doing the work anyway, I might as well earn a master's out of it. And so I used that and found it was a very lucrative project. The only things that would compare with it would be things like shipping and large properties. And I always found property to be risky because of location. You know, you can't control what happens around you. Ships I found a bit boring, and I've always loved aviation, and so that's why I settled into aviation as the concept. But the medical side will come back. If there's time, I'll share a little bit about what we're doing in future. We moved forward with those concepts. I did market research. I went to air shows around the world and did questionnaires with people from different companies, people who were buying planes, so that at least I knew that their input would be valid. And that market research, financial feasibility, and technical feasibility were the main cornerstones of what I did. And I went step by step. Every time I finished a phase of those studies, I would move up a level and think, okay, it's fine for me to now invest more time and money into this project. And just kind of through my medical practice, where I do mainly botulinum toxins, fillers, the aesthetic medical side of things, I funded most of the project. We were able to find small public funding avenues as we progressed once we had our patent granted. But what happened with that is it's helped us to move forward in a faster way. So still the bulk of the funding comes from my practice. And that's another thing that I looked at as a challenge at the beginning is we looked at the funding. And I thought to myself, based on everything we know, it may cost $1 billion to do this project. But as I learned and as I worked and as I moved forward, I found that estimate going down and down and down and down. And eventually, you know, we've been doing things here for hundreds of thousands of rands that would cost a company in the UK, for example, possibly millions of pounds to do. And this doesn't mean that we're cutting corners or that we're making inferior products. It means that we're able to experiment and we're able to research and do things at a low cost way, or bootstrapping in a way, so that we don't put the company at risk of going bankrupt unnecessarily in the early days when we should be really just putting everything we can into exploring options and how to make things fly. But we sat back, I spoke to the engineers, and we thought, look, we can either keep looking for money from various avenues, governments, but people are scared to invest into projects that don't exist. You know, in some countries, it is easier to go to an air show with drawings of a new type of plane, which is something that Eclipse Jet did, and almost to get people to give them deposits. But especially when you haven't built something before in this space, when it's a novel type of airplane, people are not really willing to do that. And so what we did was I thought, let's start moving forward. Let's build something. And so we built the 8th scale model, which was a 2-meter model. It took off vertically. It showed us a little bit about how the airplane works, where the limitations are in the fan placement. There's a cat that'll walk across the screen. Don't mind her. She's allowed to do whatever she likes. So then it taught us that the fans needed to be close together in order to fit into a wing so that we could achieve true business jet flight. But you know, a toy drone has it spread out like a square, and that was something that we weren't expecting too much, but it taught us quite quickly. From there, we've moved on. We've built new models. In between that time, we were invited to eBase in Geneva to the air show, and we displayed our 8th scale model. We were given the space for free, which I think is quite a nice compliment as well. And we were invited to speak at the Royal Aeronautical Society in London. I went, I did the talk, I was very excited. But what happened afterwards is that there was somebody from a company called Callan Lens in attendance. And he came up to me and he said, I really like this project. We've been working on a control system, the balancing system, which for us is one of the 6 critical subsystems that needed to be de-risked. And he said, well, you've got this plane, you don't have a subsystem. We have the control system and we don't have a plane. So can we work together? And we agreed to work together. They've been working on the control system since then to refine it to work for our plane. And the two quarter scale models, the 4-meter wingspan models that we've now built, are actually going to them in a few weeks' time so that they can actually implement that system and do the flight testing in the quarter scale. So the quarter scales are more advanced than the eighth scales, not just in size, but also in the intricacy of the maneuvers that they'll be able to perform, and in all of the mechanisms that we've now installed. In full scale, it'll be easy to build and install, but to do it at the quarter scale, we found also to be quite a challenge. And the truth is, again, to build these, to have them built by an international company that builds these would have, again, cost millions of dollars. But we were able to do that for a couple of million rand. And, these are fully functioning. Any engineer in the world can dissect this and open it up and they won't find problems. So this is something that I found as we progress, we keep learning, we keep making new ways of doing things. We've also attracted the attention of Amazon Web Services to the extent that they've signed an MOU with us to provide us with future robotics and solutions that we can use in our factories, but also possibly to tie in with their satellite capabilities as we fly. The full scale model then is the interesting one. If I look back to 2012, if I knew how much I would have to learn to be able to do what we're doing, or how much work it was, I might not have started. But I don't regret that I did it, because I've learned, I've studied dozens of books on engineering, on patenting, on the legal side of things, finances, international trade, computers, robotics. And it's just taught me so much and taught our engineers who work with me so much. We started building full-scale test mock-ups. I built a nose. I built it myself because I wanted to learn what carbon fiber and fiberglass was capable of and what it would take, what the process was like. I then moved on. We started building the pictures that I show you. If you skip to the next slide, that's the picture, or it was the bigger one. But even if you look on our Instagram or our website, you'll be able to see the full scale nose. It's the first 4 meters of the airplane. We'll actually be taking that to the air show next week in Waterkloof at AAD. So if any of you are planning to come to the air show, it'll be nice to have you there. What we've done is we've made these LED screens to visualize the rest of the airplane. So everything from the rest of that nose will be visualized on an LED screen, and we'll be able to show the missions. We'll be flying the plane, almost like a virtual flight that will show people at the air show. But the plan with that is to continue to build it, and then to do a hover demonstrator. And from there, we believe it will be far enough for people to look at it and say, okay, well, a thing of that size can actually hover. That means that we're happy to start investing more or giving deposits for the airplanes. As far as I'm concerned about whether or not we'll get this to fly, I'm 99% sure that we are there. There isn't anything that we haven't de-risked that could derail the project. And so I'm very optimistic about the project. I'm very optimistic about our country and our continent. I think that people are too negative. I think the news is too negative. But I do think where there are challenges, we can work to fix them. And I'll give you an example of what I've seen firsthand is the HIV pandemic that we faced when I was working in Baragwanath Hospital as an intern. We used to put people on the bed, in the middle of the bed, and the ward would still not have enough space for everybody. But once there was a decision to take action from the government side to start giving people ARVs, to start fighting HIV, if you go to Barra today, it doesn't look like that anymore. There aren't thousands of people dying and suffering because of HIV. And it's just one small example of what can happen if people put their minds together and they focus on fixing special situations. And so we here in South Africa. We're staying here. We want to build. We want to build the airplanes here and export them to the rest of the world. And we are, again, in a lucky position that we have bilateral agreements with the likes of the USA, for example. where airplanes can be manufactured here and exported. So, sorry, is someone asking a question? Oh no, nobody. Okay. I think somebody's mic is on accidentally then. Some of the other things that we have faced, again, like we said, capital. I can hear myself now.
Dr. Reza, I'm going to mute all, and then if you can unmute yourself, please.
Okay, sure.
Okay, please proceed.
Okay, great. So going forward, the things that we need people to understand is that we have a lot to offer as a continent. We have expertise, we have experience, we have natural resources, we've got the people, we've got everything that we need to make a success of a business like this, which is high technology, it's advanced. And what we identified as one of the gaps was obviously to upskill and educate people to fulfill the various roles that we would need to fulfill in the company. And that's part of our plan. It's part of our technical upskilling as we proceed through the company. And I wanted to model what I found in medical school, which was, studying a book is one thing, but when we partner with a university and we're able to give people real experience, that's a much better experience. So we've already been in touch with Wits University. We've signed a letter with them to say that we would function as a platform for people to come in and learn and grow with our company so that we can increase the capabilities of the people, not just for our company, but for other aerospace companies in the world. I think that the role of innovators is very important in this. I long ago, when I was a young student, decided that I would never try to rely on any government or on somebody who would, give us anything. It was always the idea that if I wanted something, I would make it and I would figure out how to do it. If I had to, again, look at where we are now in this project, just to give you an example, to have done this in the USA as somebody who didn't know anything about aerospace, if I then hired engineers and started hiring technicians to start building and to get where we are, we would have had to spend probably about $50 to $60 million, and that's no exaggeration. But again, just through innovative thinking, through learning, through optimism and perseverance, we were able to do that for less than 20 million rand to get to where we are right now, which includes our exorbitant patent fees, which is, again, another joke. I really hate this because I don't know if anybody finds me funny or if they are offended by my joke. But anyway, this is really what I have to say about the project. I do have some other projects in the pipeline. I find that when you are an innovator, and I think everybody can be if they just decide to be, you don't really stop. And things like using stem cells to produce meat that doesn't need an animal to be killed, but you can still be eating actual meat cells. This is one of the things I'm working on, using stem cells to treat various diseases and 3D print organs, looking for more innovative ways to reach space. These are all ideas that are in the pipeline, as well as a breech device, a device to deliver babies who are stuck in breech, who can't receive emergency medical care. So the idea is not to limit yourself to what you think you should be limited to. I've heard many times as I walked into rooms with, again, like engineers, for example, on the airplane project or other projects, where someone would say, but you're a doctor, why are you working on a plane? And I'd say, that's not a disability about what I can or can't do. It doesn't matter that I'm a doctor. When you are working, you're innovating, you look for various pieces of information or ideas from different fields and you bring them together and you take them to places they've never been. And that's the best way to create something that the world has never seen before. Because if you follow the rules and just do what everybody else is doing, there's no way that you'll overtake anybody who's been doing that already. So again, thank you very much.